Welcome back to VRC Smart Edu channel. So this is the last part of gravitation chapter we are going to just look after. Subscribe to our channel for more videos. In this video we are going to look after quickly the formula revision and all the problems based on the gravitation chapter, and this is a part 6 video. So let us quickly move on to the formula revisions. Let's get going. So first we are going to see about the Kepler's law. Already we have derived all these things in our previous video. The link are provided in the description. You can go and check it out. So now let us just revise the formulas. So Kepler's second law. So what is Kepler's second law? dA by dt is equal to L vector by 2m. Already we have derived this in our previous session. So if you want the derivation, go to the previous session, watch it and come back here. So what is that? dA by dt is equal to L by 2m. Okay, L by 2m. Okay, right. So and we also saw about Kepler's third law, right? So what does Kepler's third law states? Kepler's third law states that the square of the time period is directly proportional to the cube of the semi-major axis. So your t square is directly proportional to a cube, right? So your t square is directly proportional to a cube. Now what is your t square? What is your t square? Your t square is time period of revolution. T square is time period of revolution, right? Then what is your a cube? Your a cube is semi-major axis of elliptical orbit. Semi-major axis of elliptical orbit. Okay, clear? Right. Now we are going to go for the next part, that is universal law of gravitation. What is universal law of gravitation? We learnt about F is equal to capital G m m1 m2 by r square, right? Okay, very good. So next we are going to see the vector form. Your F vector is equal to G m1 m2 by r square into r cap. So what is this r cap stands for? R cap shows the direction for us. Okay, so your masses are constant. Your mass is not coming under vector, so you are not showing any vector representation for mass. Okay, so that r cap is present for showing the direction, remember that. Then acceleration due to gravity. So it is very important, right? Acceleration due to gravity. Your small g is equal to capital G me by re square. Me is what? Me is mass of earth and re square. Re is radius of the earth. Then g at altitude h, right? Your gh is equal to gm by r plus h the whole square. So this is the first formula that we are learning. Okay, so this is for gravitation, acceleration due to gravity at certain height. Another formula is also there that we are going to see here is gh is equal to g into re by re plus ht whole square. That is another formula that we are going to see. That is what your gh is equal to g into re by re plus h the whole square. Okay, so re what? Here also re is nothing but the radius of the earth. Okay, so gravitation at depth is what we are going to see later. What is gravitation at depth? At certain depth we are going to see the acceleration due to gravity. It is gd is equal to g into 1 minus d by re. Here also what is re? Here also re is radius of the earth, right? Now we are going to gravitational potential energy. Three formulas we are going to see here. Okay, what are the three formulas? First one is U is equal to minus G capital M small m into 1 by R2 minus 1 by R1. 1 by R2 minus 1 by R1. This is your first formula. Okay. So next, your second formula is, we are having certain conditions that I am going to say now. The condition is nothing but R1 is at infinity position, R2 is at R. Then your U is equal to minus G capital M small m by R. This one I hope we already studied, right? Next, your del U. Here the condition is del U. Here condition you are having. Before that, let us see the formula. mgh by 1 plus h by r is the formula. Here the condition is h is very small than r. That is a condition. H is very small than r. So then your del U is equal to mgh by 1 plus h by r. Clear? Hope you got the formula. Next, we are going to see the gravitational potential. So what is your gravitational potential? V is equal to minus G m by r is your gravitational potential. Next, moving on to orbital speed. So your V naught is equal to under the square root of G m by r is the formula for orbital speed. Okay, orbital speed is also called as critical velocity, right? So that is what. Then escape speed. What is the formula for escape speed? Your VE is equal to under the square root of 2gm by r. It is the formula for escape speed. Clear? Got that? Okay, right. Now we are moving on to the next topic. Okay, our next topic is about the time period of the satellite. So come on, let us talk about time period of the satellite. Okay, so see, time period of the satellite. I'm just writing now time period of the satellite Okay, so what is time period of the satellite? Your t is equal to 2 pi into r plus h whole to the power of 3 by 2 divided by under the square root of gm is the time period of the satellite. But we use it very frequent. We are not going to use this formula frequently. Okay, but another condition, you see, when h is very small than r, at that time your time period of the satellite will be 2 pi under the square root of r by g is the formula. So this formula at least we use a little bit. Okay, but we are not going to use this both of the formulas for frequently. We are not going to use these formulas frequently. Okay, now you just see another formula we are having for showing the time period. That is, your t square is directly proportional to r cube. Your t square stands for time period of revolution of the satellite, and your r cube is standing for the radius of the orbit. Clear? Got that right? Okay, so this is a very important formula we use in most of the cases for solving variety of questions also. So remember this formula carefully. Your t square is directly proportional to r cube. R cube is the radius of the orbit. Clear, everybody? Okay, now we are going to go for energy of the orbiting satellite. Okay, so what is all about the energy of the orbiting satellite? Here we will be seeing about the kinetic energy, potential energy, as well as total energy. So your kinetic energy is equal to capital G small m capital M by 2 into R plus H. It is a kinetic energy formula. Then we will be dealing with the potential energy also. So your potential energy is equal to minus capital G small m capital M by R plus H. So this is your potential energy. Then we are going to calculate the total energy next. So your total energy is nothing but kinetic energy plus potential energy. So your kinetic energy and potential energy, when you add both together, you will get your total energy as minus G small m capital M by 2 into r plus h. This can be denoted as your total energy is equal to minus kinetic energy, which is equal to potential energy by 2. All are equal only. Okay. Now let us move to the next question. Question states that explain why the weight of your body becomes zero at the center of the earth. So for this question we are going to use the formula gravitation, acceleration due to gravity at certain depth, because they have asked the center of the earth. Center of the earth in the sense you just consider the earth, that circle is as your earth and the midpoint as your center of the earth. And now you are going to see that radius of the earth is from the center of the earth to the surface of the earth. So what we are going to say, the weight towards the center of the earth, that means your radius is equal to your depth. So your d is equal to r. That means instead of depth you can substitute the radius. Okay, your gd is equal to g into 1 minus r by r you can write. That means what you can do now, your r and r you can cancel. While you are cancelling the r and r, you will get your gd is equal to g into 1 minus 1 you will get. R by r cancel out means you will get 1, right? So then your gd is equal to g into 0. 1 minus 1 is 0. Anything into 0 is 0. So your gravitation due to depth is 0. Then your weight of the object at the center of the earth will also be equal to 0. This is why your weight of the object at the center of the earth is 0. Clear? Hope you got this question, right? So this is how you would explain for this question. You will explain the answers, right? So now I'm going to read the question. A body weighs 63 Newton on the surface of the earth. What is the gravitational force on it due to earth at a height equal to half the radius of the earth? So what is the thing you have to find here? Gravitational force on it. Gravitational force, okay, of the body due to the earth. That is what you need to find here. Let me give you the hint for this question. All the hints, whatever you have to use. Okay, and final answer you are going to find. This is a homework question. You're going to solve this question and post the answers in the comment area. So I'll be saying whether it is correct or wrong in the comment area. So I hope you will post the answers in the comment. So let us see the hints now. So your weight is given as 63 Newton, right? So actually your weight is the force exerted due to gravity on the earth, right? So here we are going to use a formula for acceleration due to gravity at certain height. That formula we are going to use here. So gravitation due to height, what is the formula? G by 1 plus h by re the whole square. That is the formula. And another one hint is given that your height is half of the radius is your height. So your h is equal to re by 2 is another hint for you. So using that hint, that is from the question, you have to just substitute and find the answer, and that is the homework question. Kindly do it. Okay. Now the third question we are going to see is the critical speeds. You have to compare the critical speeds of two satellites if the ratio of their period is 8:1. So critical speed is also orbiting speed, right? Right. So you are going to use the formula of orbiting speed. Already we learned the formula. Okay. So what is the formula we learned? So VC1 in the sense your velocity of the critical speed. That is what? VC1 is equal to under the square root of G capital M by R1. Okay. Now VC2, because two satellites we are going to compare. So VC2 is equal to under the square root of capital G M by R2. Now what you are going to do is you are going to compare the ratio. So you have to take it in ratio. VC1 by VC2 will be equal to R2 under the square root of R2 by R1 you will get. So you are going to consider that as your first equation. You are going to consider that as your first equation. Okay. Now what we are going to do means we are going to take the time period. What is the formula? We know now, only we study, no? Your time period, T1 time period, the whole square will be directly proportional to R1 cube. Now only we study, right? I told very important. See, now we are using in this question. So T1 square is directly proportional to R1 cube, and also T2 square is directly proportional to R2 cube. Then your T1 by T2 will be equal to T1 by T2 the whole square will be equal to R1 by R2 the whole cube. Can we write in that way? Yes, of course, right? So we can write in that way. Later, what we are going to do means your T1 by T2 the whole square, they have given the time period of the satellite as 8 by 1 the whole square, which is equal to R1 by R2 the whole cube. Okay, so now if you just square 8, okay, you will get 64, right? 8 square is 64 and 1 square is 1 simply. So your R1 by R2 is, what you are going to do is this cube root, you are just cube, you are bringing to this side. So 64, when you just cube it, you will get 4. Okay, 64, when you just cube it, you will get 4. So you can write that, you can write 4 by 1, you can write like that. So your R1 by R2 is equal to 4 by 1, you will just get like that. Okay, so this is your second equation. So from your first equation and second equation, what you can tell is, see, I'm just saying that your 64 by 1 is R1 by R2. So your square root, cube root of 64 is what? Cube root of 64 is just 4. That is only I have used there. Okay, cube root of 64 is 4. That only I have used there. So R1 by R2 is equal to 4 by 1. That is your second equation. Now from first equation and second equation, what you can say? First equation we got is VC1 by VC2 is equal to the square root of R2 by R1. That is what the first equation that we got, right? And the second equation now we got is R1 by R2 is equal to 4 by 1. Then you have to consider your R2 value as 1, R1 value as 4. So substitute in that area. Okay, so how you will get? Your VC1 by VC2 is equal to, under the square root of 1 by 4 you will get. Okay, your VC1 by VC2 you will get, which will be equal to under the square root of 1 by 4. Okay, under the square root of 1 by 4. Now what you are going to do is your VC1 divided by VC2 will be equal to 1 by 2. See, under the square root of 1 by 4 means you have to just see the 2 square is 4. So it is 1 by 2. So your ratio they have asked, right? The ratio is 1:2 is the ratio. Okay, clear? That's all. Very important question. You can just practice this question. Okay, so thank you so much for watching this video, and kindly subscribe to VRC Smart Edu channel for more videos and more updates. So hope you remember that I gave you the practice question, one homework question. Kindly complete that and post the answers in the comment area without forgetting. I will check and I'll say the correct answers in the comments. Okay, thank you for watching, and kindly follow our channel for more videos and more updates. Okay, this is the last part of this chapter, and I'll be coming with the next chapter.